Good evening, all, and I am Nisha. I am a host for this session. Now, I welcome you all to the first session of our 5 days faculty development program on digital image processing using Matlab, organized by Institute for Engineering Research and Publication (IFRP) in association with our academic partner PES Institute of Technology and Management, Shimoga. And before we get into the session, let me give a brief introduction about IFRP. And Institute for Engineering Research and Publication, IFRP, is on its way to digitalize innovation processes through our professional networking services and thus providing an integrated virtual scientific community, mutual engagement, exploring potential of researchers, creating a cooperative and collaborative academic environment. And IFRP supports the professional growth of its members by providing opportunities of professional networking, lifelong learning, and career development by organizing scientific conferences, faculty development program, workshops, webinars, book chapters, seed funding chapters, special interest groups, research publication, membership, industry institute interaction, etc. Now, coming to the first session, before inviting our speaker of the session, Dr. J. Somashekar, to take the spotlight, I would like to give an introduction about him and his expertise. Dr. Somashekar received a PhD degree in the computer science and engineering from JNTUA, Andhra Pradesh in 2017, and MTech degree from the National Institute of Technology, Karnataka, Suratkal in 2010. He is currently working as a professor and head of CSE department, Gopalan College of Engineering Management, Bangalore. As a resource person speaker, he has delivered 145 technical talks of AICTE FPDs and ISTE FDPs, STTP and UGC FDPs webinars in 12 states of the country. He got all India ranks of 43 in the GATE exam with a 98.4%. He has 16 years of experience in teaching and 6 years of experience in research. He also received an Innovative Collaborative Researchers Award in Medical Imaging for research collaboration with Dr. Ching Hong Lai, Director ITRI Taiwan, by WRC in association with United Medical Council. Also, he have received a Best Outstanding Speaker Award and the Best Paper Awards in the conferences. He has conducted various FDPs, AICTE, STTPs, and SDPs, national conferences, workshops, and national webinars as a convener coordinator. His current research interests include image processing, data science, machine learning, big data analytics, and ML for cybersecurity. Now, Dr. Somashekar can deliver his keynote speech.
Thank you, madam. Can I share my screen, madam?
Sir, you're audible, but your screen is not visible, sir.
1 second.
You can share your screen now, sir.
Yes, madam. Is it visible, madam?
Yes, sir, it is.
So thank you for introduction, madam. So good afternoon, all the participants. So welcome to 5 days FDP on digital image processing using Matlab, organized by IFERP. Already madam explained briefly about what is IFERP and the significance and the roles, all those things. So coming to the first day of digital image processing using Matlab FDP. So before going to the session, so I'll explain briefly. So what is the agenda of today's session? And after that, we will see one by one in detail about digital image processing and also Matlab and the hands-on session using Matlab. So coming to agenda of today's session. So first we will see what is digital image and what are the types of digital images and what is digital image processing and what are its applications. so that you can understand the significance of digital image processing. That's why we'll discuss various applications of digital image processing and also digital image processing techniques, because we are looking for digital image processing using MATLAB. So we have to start with basics to various digital image processing techniques with hands-on by using MATLAB. Of course, we have other tools also, but our FDP, we are focusing on digital image processing using MATLAB. So whatever techniques we are going to discuss, that we will discuss with MATLAB hands-on also, so that you can understand how to implement by using MATLAB programming and various tools for digital image processing. So just I'll give brief list of digital image processing tools, but we are going to opt for MATLAB. That is our scope of our session. Of course, we have Scilab, ImageJ, like that, various tools also available, but our focus is mainly on MATLAB. By using that, we can go for implementation of the various image processing techniques for various applications. And also introduction of MATLAB. Today we'll try to complete introduction of MATLAB and how to install MATLAB and what are the main functions in MATLAB, and with hands-on that we'll try to complete today. Maybe tomorrow's session onwards, we will see image processing techniques by using MATLAB. So that means almost most of the basic concepts we are going to complete today by using MATLAB, as well as theoretical concepts. And also resources. Suppose if you are looking for further enhancement of the MATLAB as well as digital image processing, I will share some of the resources. Based on that, you can enhance your image processing skills as well as MATLAB, because within 5 days, of course, every day we have around 90-minute session. So in this 5 days, we can't complete entire digital image processing or MATLAB. So I will show the path of digital image processing by using MATLAB. Based on that, you can go for further enhancement, or you can explore further digital image processing techniques as well as hands-on by using MATLAB. So because of that reason, I will share the resources at the end of the session. So by using that, you can go ahead to explore more about digital image processing as well as MATLAB for implementation of the various digital image processing techniques. So this is a brief agenda of day one. And after that, next day, we will see how to implement various techniques by using MATLAB, all those things. So basically what I'm trying to explain, whenever if I go for any image processing techniques, first I will explain theoretical aspects. After that, I'll explain implementation by using MATLAB hands-on, so that you can understand. Without theoretical explanation, or maybe without mathematical intuition, if I go directly implementation of the MATLAB, so maybe you will get output, but we don't know exactly what is happening beyond that. So because we have direct MATLAB functions, by using that you will get output easily. For example, if we take contrast enhancement by using histogram equalization, directly I can go for imhist. So maybe histogram equalization or imhistogram equalization, etc. So directly you'll get output, but exactly what is happening we don't know. So that's why we have to go for what is histogram, what is histogram equalization, how to go for contrast enhancement by using the algorithm. After that, hands-on by using MATLAB. If you go with this flow, you can understand better, and based on that, we can go for any new algorithms or techniques in the image processing that you can implement by using MATLAB. So that is the flow what I'm going to explain for these 5 days, 5 sessions. So before going to the definition of digital image, as you can see here, one image is worth more than 1,000 words. So what does it mean? Any image or picture may convey an idea more quickly and efficiently than a written word. Suppose if we take latest as video or image, you can remember easily and you can convey the message quickly and anyone can understand. But if you write one page or maybe 1,000 words or maybe two pages, etc., it is difficult to remember and difficult to convey the message to the users or maybe participants. Because of that reason, images plays a vital role. Because of that reason, we have various applications also nowadays in real world. So we have a huge number of, every day we are being influenced with these images. So when you go to the office, biometric, that is one of the digital image processing application. When you go for health checkup, maybe they will take scanning and they will say immediately you have some disease or not. That is also one of the image processing application. When you go for traffic, so whenever if you violating the traffic signal, immediately you will get notice because you are violating, how it possible. So number plate recognition, after that you will get notice. So like that, every day we are being influenced with this digital image processing applications. Now we have deep learning. So deep learning is incorporated with these digital images, and we have huge number of applications. So we can process by using various deep learning techniques of the images, digital images. Based based on that we are able to achieve so many applications also. So that's why we should know the basics of image processing. Based on that we can explore more in digital image processing or maybe machine learning or in data, what we can call it as a deep learning. So everywhere we require the basics of image processing. So based on that, depends on your research or maybe depends on your requirement, we can further explore that concepts and implementation also. So first we will say, so what is the definition of a digital image? So I'll give simple example what we studied in lower classes. Based on that you can understand. So we know what is matrix. A matrix is nothing but arrangement of elements in rows and columns. Let us assume if I take A equal to 5, 6, 7, 8. So this is a matrix. We can call it as a square matrix because we have number of rows equal to number of columns. That's why we can call it as a square matrix. Let us assume, I'll take one more matrix. Let us assume capital B. So make it as a non-square matrix, or we can call it as a rectangular matrix. So 6, 9, some 8, let us assume. So this we have 2 rows and 3 columns. We can call it as a non-square matrix or rectangular matrix. So these are the basic things what we studied in 7th or 8th class. Now, why we have to discuss this one? When I go for digital image, whenever if I go for any image, we have to represent by using matrices. So a digital image is nothing but a matrix in which the elements are nothing but intensity values or color of an image. So depends on the color, it will take automatically value. So whatever it may be color, if we take, let us as black and white image, so black means it will take 0, white color means it will take it as a white. So when you go for Matlab, so just you have to give the input, then automatically it will convert it into matrix notation. Then you can go for further processing. It may be contrast enhancement, or it may be segmentation, or it may be classification, or it may be object recognition, or it may be object tracking. Whatever it may be, depends on the application, we can go for further. So that's why we should know what is the matrix, and that digital image we are going to represent by using matrix. So this is a square matrix, and this is nothing but color, or we can call it as a, technically speaking, intensity value of a pixel value. So this is a simple definition, but here we have a lot of background is there. Whenever if I go for image, we have to go for first pixels. So let us assume if we take here, let us assume I want to make it as a pixels. Suppose if we take any image, so we have a pixels. Let us assume, so this is 1 pixel, this is 1 pixel, this is 1 pixel, this is 1 pixel, this is 1 pixel. So how to go for a mathematical representation? So for that we have to go for sampling. So let us assume, so always starts from 0 to n. Let us assume m cross n. If we take, let us assume m cross n. If we take, so it will take m minus 1 row, n minus 1 columns. So let us assume 0, 1. This is 2 by 2 matrix. But just for better understanding, I'll go for specific to 2 by 2 matrix. So these are nothing but pixels. So 0, 0 is 1 pixel, and 0, 1. That means first row, second column is 1 pixel, and second row, first column is 1 pixel. So here we have to start row index and column index from 0. Suppose if we have a m cross n matrix, so number of rows are m minus 1, 0 to m minus 1, that is the meaning. And whenever if I take n columns, number of columns are 0 to n minus 1. So we have a pixel that we can convert it into mathematically. So because we are talking about spatial coordinate system, x and y axis. So here 0, 0, 0, 1, 1, 0, 1, 1, second row, second column. So this is this we can call it as a pixels. So this is a sample point. That means we can call it as a first row, second column, or we can call it as a pels, P-E-L-S, pels, or we can call it as a pixel. So simple word is pixel. This we can call it as a pixel. Now, each pixel having some color. Whenever if I take each pixel having some color, for that we have to go for mapping. That is a two-dimensional function f maps. So that means these are the xy. Xy is nothing but pixel, spatial coordinate system, and this we have to use some function f maps. So that then we'll get output that is called real valued function, that is called intensity value. So this is that will map to f of xy. So this f of xy is nothing but a image. So that's why basically here what we have to do, this is the pixels. Now each pixel having some color, that is called f of 0, 0, f of 0, 1. So this is nothing but some real value. So f of 0, 1, 0, f of 1, 1. So that means, so each pixel having some function value that is called color, that we can call it as a, let us assume 80, 90, 100. I will tell you what is the range also, 150. So this is a final image. So finally, an image is nothing but two-dimensional function. X indicates rows, Y indicates columns. So f of x is nothing but an image. Because matrices, we can call it as a matrix is nothing but image. Same thing here. I'm talking about spatial coordinate system. That's why we can represent it as a f of xy. F of xy is nothing but an image. Xy is nothing but coordinates, or we can call it as a pixels. So finally, an image representation is nothing but f of xy, or we can write it as a matrix notation also fine, f of xy or a. But most of the techniques what we are going to implement by using the representation f of xy. So this is the final conclusion. An image is nothing but a two-dimensional function f of xy, and the elements of the function, or we can call it as a matrix here, nothing but intensity or color values, and x indicates rows, y indicates columns. Always row or column index starts from 0. If you have a m cross n matrix, number of rows are 0 to m minus 1, and columns are represented by 0 to n minus 1. So this is a simple definition of a digital image. Here you can see the definition. An image is a two-dimensional function, all those things what I have explained. So x, y, if x and y and the amplitude value, that means f of xy is nothing but amplitude value, or we can call it as a color or intensity value. So this is a simple definition. So final conclusion is a digital image is nothing but two-dimensional function or matrix in which the elements are nothing but color or intensity value. So whatever I have explained, you can see clearly graphical representation. We have pixels. After that, we have, this is called sampling. Finally, we have to go for quantization. Sampling and quantization leads to digital image. So this is called digital image. So finally, we got a digital image that is nothing but two-dimensional function or matrix. In general, the intensity values or color values lies between 0 to 255. Always 0 less than or equal to f of xy. F of xy, or if you are going for matrix notation, a suffix ij. So any notation we can use, but f of xy is the preferable notation to use for image less than or equal to 255. So always the color or intensity values lies between 0 to 255. So this we can call it as a 8-bit image. We can call it as a 8-bit image or grayscale image. So what is the meaning of 8-bit image? All the values lies between 0 to, so 2 power 8 minus 1. 2 power 8 means 256. That means total intensity values are 256, but the values ranges from 0 to 2 power 8 minus 1. So this is nothing but elements of the matrix or color values of a image. So 8-bit image is also called as a grayscale image. So this is one more notation. Grayscale image is nothing but 8-bit image, and the values are lies between 0 to 2 power 8 minus 1. So depends on the color, it will take automatically. No need to worry when you are looking for any Matlab or Scilab. When you give input image, automatically depends on the color, it will take. I will show during hands-on, so how to display the values of the matrix also, so that you can see the values of the color or intensity values clearly. So same thing what I have explained. So this is the pixels, and finally we converted into digital image. And if we take one simple example, image f of xy equal to matrix notation. So here minimum is 0 value, maximum is 255. So maybe if you are looking for matrix notation instead of function f of xy, we can write like this: a equal to a0 0. So here 0 to m minus 1 rows and 0 to n minus 1 columns. So that means it is a m cross n matrix. A is a matrix of size or order m cross n. So preferably we are going to use f of xy. If we are looking for even matrix notation also, we can go for a equal to a00 a01. We know what is the meaning. A00 means so first row first column, a01 means first row second column, like that. So this is the digital image we have. If you take let us assume this is the pixel, and the pixel value is 103. So f of 11. So actually pixel is 1011, and pixel value or intensity value means it is a two-dimensional function f of 11, that is 103. So of course we are not able to see in the image 103, but if we go for processing by using Matlab or any other tool, we can find the value of this pixel f of 11 is 103. Depends on the color it will take, because this is a grayscale image. So 11 is a pixel location, and 103 is nothing but pixel intensity value or color value. So if you take last pixel, so the pixel location is 2724 and 233. See, this is the row, this is the column, and the intensity value or color value is nothing but pixel intensity value is 88. If you take part of this image, let us assume here I'm taking rows from 645 to 650 and columns, then the image looks like this. So depends on the color. So the values are 83, 82 like this. So this we can't see directly in the image, but when you process the image by using Matlab or Scilab, we are able to see the values of this color. So here you can see 83, 82, 77. That depends on the color. It will take automatically. Yeah, someone raised the hand. Let me check. If you have any queries, you can type in the chat box also. I will read it and answer your query. Or maybe at the end of the session, I'll give 10 minutes for discussion, or maybe any queries. You can ask that queries. I'll try to answer all the queries. Yeah, thank you. Amita Raghu. Yeah, thank you. Thank you. You can type, no problem. Later also I will read it and answer the queries. Okay, fine. Yeah. Now, if you take grayscale image, I already said the grayscale value lies between 0 to 255. If we take this is the original image, and I'm taking part of that image, and when you convert it into matrix, the gray values like this. So 10, 10, 16 like this, because depends on the color, automatically the grayscale values are assigned to each pixel value. That is called intensity value or colors. So when you take color image, so here color image is nothing but RGB image or 20. I will explain clearly here. So whenever if I take grayscale image, let us assume so A equal to or f of x y equal to like this. So this is a grayscale image. So 20, 30, 60, 70. This is clear. So this is a grayscale image, and each pixel having only one value, and the values are lies between, whenever if I take any value, let us assume A is a or f of x y lies between 0 to 255. So this we can call it as a grayscale image, or we can call it as a 8-bit image. So this is clear what we discussed. When you come to the color image, each pixel having combination of 3 colors, that is called RGB. That's why we can call it as a color image or RGB image, or we can call it as a 24-bit image. Suppose if I take, let us assume capital A equal to or f of x y equal to, I'm taking 2 by 2 matrix. So I'm taking RGB image. So 20, first pixel value having 3 colors, 20, 30, 60. So this is the 3 channels values, and second pixel having 30, 60, 70. This is the second pixel value, and here 70. Here also minimum value is 0, maximum value is 255, 90. Let us assume 0, 15, 30. So this is called color image. So color image means it is the RGB image, and each pixel is composed with 3 channels. That is called, this is called red, or red, green, blue. This we can call it as a RGB image or 24-bit image. So that means capital A is a combination of 3 channels. So I can write, even when you are using Matlab or Scilab, we can't display the matrix looks like this directly 3 channels. It will display 3 channels like this. So this is R, this is G, this is B. That means 3 matrices. So what is our first pixel values of all the elements? 20, 30, 70, 0. So in each each pixel, first element is nothing but red color indicates. Next, second color indicates green. So 30, 60, 80, 50. That is the second one. And third one is nothing but 60, 70, 90, 30. So that means a color image is composed with 3 channels, that is called 3 matrices. We can call it as a RGB. So R indicates first intensity value of each pixel value. So 20 here first intensity value, 30 first intensity value of the second pixel value, and 70 third intensity first intensity value of third pixel value, and here 0. So that's why that is nothing but red channel. So red channel, or we can call it as a red color matrix. So that is called R. So that is the first one. And second one, green channel. Let us assume here second pixel values, each pixel second value 30, 60, 80, 15. Similarly this one. So, but even when you are applying MATLAB also, we can display RGB only, not at a one matrix with RGB colors like what we written in the matrix say. So we have to go for separately. So whenever if you want to process the image, maybe further contrast enhancement or segmentation, etc. for color image, so we have to process 3 channels. But whereas if we take gray channel, we can go for only 1 channel. That's why always we are trying to convert a gray color image to grayscale image. Why means we'll try to minimize the time complexity. Otherwise, we have to process 3 channels. It will take a lot of time and processing all those things. Because of that reason, always we are trying to convert the color image into grayscale, and after that we have to process for either classification, or it may be segmentation, or it may be contrast enhancement, etc. So that we will see later when you come to the hands-on how to convert and what is the significance, what are the advantages, and what type of applications we are going to solve by using a conversion, all those things. So this is the difference between grayscale image and color image. And I mentioned this is called 24-bit image. Why we can call it as 24-bit image? It's a combination of 3 8-bit images. This is 8-bit image, R is 1 8-bit image, and G is 1 8-bit image, and B is 1 8-bit image. What is the sum of all these 3 8s? So it's a sum of 8 plus 8 plus 16 plus 8, 24. So that's why we can call it as a color image is nothing but 24-bit image. So grayscale image is nothing but 8-bit image, because each pixel having only one value, and the values are lies between 0 to 255. That means 0 to 2 power 8 minus 1. That's why we can call it as a 8-bit image. And here when you come to the color image, we can call it as a 24-bit image, because each pixel is a combination of 3 colors. That's why 8 plus 8 plus 8. So that's why we can call it as a 24-bit image. So this is the difference between grayscale image and color image. And same thing here, you can see the example. This is a color image, and when you take a small part of the color image, it's a 3 components, or maybe 3 channels RGB. So R is 1 matrix, G is 1 matrix, and B is 1 matrix. It's composed with 3 matrices, or it's a combination of 3 matrices, or GB. We can call it as a 3 channels, or red, green, blue channels. So now we will look at the other type of matrices, that is called binary matrix. So binary means either true or false. So here whenever if I take binary matrix, we can call it as a black and white image. So black means we can call it as a 0, 1 means white. It's like this. So 1 0 0 0. This is called binary. When you go for segmentation, we are looking for binary segmentation. There black color is the background, white color is nothing but object what we are looking. Such type of application we have to make it as a binary image. So obviously when you apply some of the segmentation techniques like thresholding, etc., the resultant matrix is a binary matrix. There white color indicates, that means white indicates the foreground, black indicates the background, and white is nothing but required object. If there is no white part, it indicates that there is no area infected with malaria or maybe cancer, etc. So such type of applications we have to go for binary images. So here only 2 values, either true or false. True means 1, false means 0. So of course we have other types of images. These 3 types of images are very important when you are looking for further concepts. Maybe we have other types also. Mainly we are focusing on grayscale image, RGB or color image, or binary image. So later we will see while implementing by using Matlab how we are going to convert RGB to grayscale, and based on that what type of applications we are going to solve. All those things we'll discuss in detail. So if we take here one digitized image, so this is the let us assume here T, I'm assuming. After digitization, so the digital image looks like this. So because let us assume 0010 like that. So this is one simple one. Whenever if you have any image after digitization, digitization is the process of sampling and quantization. Sampling means pixel value, I mean pixels, and quantization means we have to assign values to the pixel by using 2-dimensional function. What we have discussed, that is called quantization. Sampling plus quantization will leads to the digitization, that is called final digital image. So whatever it may be, the definitions, just you can remember image is nothing but matrix. So here I already mentioned, if you take 8-bit image, so what are the grayscale values? It lies between 0 to 255. That means 2 power 8 minus 1. So that is called grayscale value. That is called 8-bit image. Sometimes maybe we are looking for maybe a 2-bit image. If we take 2-bit image, so what are the grayscale values? So 0 to 2 power 2 minus 1. So in that case, it will take 0 to 3, 0, 1, 2, 3 like this. So if we take 4-bit image, how many grayscale values it will take? 0 to 2 power 4 minus 1. That means 0 to 15. So number of intensity levels or intensity values are 16. Suppose if we take 8-bit image, 256 intensity values, or we can call it as 256 gray level values. So that means 0 to 255. So whatever examples we are going to consider, all we are going to consider 8-bit images only. That means grayscale values lies between 0 to 255. Suppose if someone will ask how many number of gray values in 4-bit image, then 0 to 2 power 4 minus 1. That means 16 gray levels. If you take a 3-bit image, so 0 to 2 power 3 minus 1. So that means total we have 8 bits, 8 gray level values. Like that we can make a conclusion. So for that I given this table, but whatever examples we are going to discuss in further subsequent slides, we are going to consider only 8-bit images. Maybe when you are looking for contrast enhancement, etc., there we can consider 4-bit image or 8-bit images also. So only thing is, binary if I take blind indication, if we take a k-bit image, number of gray level values, or the gray level values range is 0 to 2 power k minus 1. That means total number of gray level values are 2 power k. If you take 8-bit image, 2 power 8, 256 gray level values, but the range starts from 0. That is the meaning here. Now we know clearly, so what is a digital image, how to represent mathematically, and what are the types of images. What we discussed so far: color image, grayscale image, and binary image, and what is the meaning of 8-bit image, 3-bit image, 4-bit image. So the image definition with various other background works completed. Now we will see what is digital image processing. So we know image, now we have to look for digital image processing. Why we have to go for processing of the digital images? So digital image means we know it's the matrix representation, and the values indicates color or intensity value of the image. So when you come to the digital image processing, it's very simple definition. So digital image processing means processing digital image by means of a digital computer. We have a digital image and we have to process by means of digital computer with the help of some algorithms or maybe some techniques. So based on that, we can go for some objectives or maybe some goals. What are that goals? We have to go for improvement of pictorial information, and we have to look for efficient storage and transmission. So what does it mean? Whenever if I take, let us assume we have an input image with low contrast, we have to look for better contrast. Or maybe whenever if I take any input image, we have a lot of noise, we have to look for noise reduction. So that is called improvement of the pictorial information. Efficient storage means that we can look for image compression. So when you are looking for data, maybe let us assume here we are talking about images. Image size is, let us assume 250 KB. So instead of that, I want to compress, make it as 100 KB. Then obviously efficient storage, we can minimize the storage. At the same time, transmission also very fast. So these type of goals we are going to achieve by using digital image processing. So always we are looking for manipulation of the digital images through digital computer. By using that, we are looking for improvement of the pictorial information or looking for efficient storage. Why we have to look for efficient storage? Instead of saving 250 KB, we can reduce the size, maybe make it as 50 KB or 100 KB. Then obviously efficient storage and the transmission also becomes fast because we reduce the size. So that is what that we can call it as image compression. So these type of objectives we are going to achieve by using digital image processing techniques or digital image processing algorithms. But here basic input is digital image, what we have discussed so far. So by using that, we are going to achieve these objectives or maybe these goals. So this is the input image. Let us assume we have a matrix. A is a input image, let us assume, and after processing you will get output image B. So maybe, or if you want to look for functions, so input image is nothing but f of xy, let it mathematically, and process means some algorithm we applied. Let us assume T is a process or maybe some algorithm or maybe transformation we apply to the input image f of xy, and the output image is nothing but g of xy. So mathematically how to write? So g of xy is nothing but output image which is having better pictorial information or maybe better contrast, that we can apply transformation T or maybe algorithm T to the input image f of xy. So this is the mathematical notation. So g of xy, simple mathematical notation. When you go for further concepts, we require other mathematical notation. That's why you can remember these are the simple basic mathematical representations whenever we are looking for some of the transformations or maybe applications. So here we can write whatever graphical representation here we have, that we can represent it by g of xy equal to t f of xy. Or if you are looking for matrix notation, So B is a output and A is a input. We can write it as B equal to T of A. The transformation, or we can call it as algorithm that we apply to the matrix A, then you will get output image B. So this is a simple digital image processing graphical representation. So the based on that we can understand why we have to look for. I will show one of the example. You can see here. So this is the original image. As you can see, this is just X-ray image. And when you processing by applying some of the image processing technique or algorithm, after processed, the output image looks like this. So obviously, as you can see, the contrast is improved, or we can look for better pictorial information. Based on that, we can look for further image analysis, maybe classification, or maybe object recognition or segmentation, whatever it may be, depends on the application. So in this case also, this is the input image A, and this is the output image, processed image B, and this is called transformation processing. So therefore P of A equal to B. So this is a simple graphical representation of a digital image processing, what we have discussed so far. Maybe one more example also. So this is a low contrast. Whenever if you have a low intensity values, which indicates low contrast, now I applied some technique. So far we don't know what type of techniques we are going to apply. That we'll discuss one by one. Maybe tomorrow we will see what are the image enhancement techniques. Based on that, how we are going to change the contrast. That means how we are going to improve the contrast. That we will see with hands-on as well as mathematical intuition, all those things when you come to the further sessions. So low contrast means always low intensity values. Here when you see the high contrast, which is having better intensity values when compared to the input, obviously we have better contrast. So here also same thing. This is input image. After processing something, you will get output image. So the conclusion is, so whenever if I go for digital image processing, means processing digital image by means of a digital computer with the help of some algorithms or maybe with techniques. By using that, we can reach the better contrast enhancement, or maybe segmentation, or it may be compression, etc. We can achieve. That are the main goals of digital image processing or objectives of digital image processing. Now here image acquisition is very important. Whenever if you are looking for, let us assume, cancer detection or maybe malaria detection or COVID-19 detection. So first we have to take an image. For that we can go for various devices, maybe camera or maybe mobile, or it may be medical, means there we can go for some microscope or etc. So if you take here, we have, this is one type of imaging modalities, and this is one type of imaging device, maybe cameras everyone knows, and this is one type of image acquisition like biometric. Whenever if you put finger, it will recognize whether the person belongs to employee or not, or he belongs to employee of the company or not. So like that we have various image acquisition devices are available. Depends on the application, we have to consider. After once if we take a image, then we convert it into digital image, then we have to go for further processing. So especially in medical, these are the medical devices for taking images. So ultrasounding image, microscopic image, sim imaging, like that we have various imaging modalities. By using that, we can acquire the image. Based on that, we can go for further analysis of the image. Without input image, then what we can do with image processing algorithms? So in image processing, we require image, and when you go for data science, machine learning, we require data set. Without this, nothing to do with any algorithm or techniques. That's why this input is very, very important. So we have various image processing techniques. So all those things we are going to discuss in detailed with hands-on by using Matlab also. Just I'm showing here what is noise reduction, input output. I'm not going to explain much about here now. When you are looking for the concepts with hands-on, at that time I'll explain what are the noise reduction techniques. Not all the techniques, whatever minimum requirements we have, that we'll try to apply, and we'll try to go for hands-on also. When you come to the noise reduction, that is very, very important as a pre-processing techniques. So for everything, I will show input image, output image, so that you can remember, because initially I have shown. So one image is better than 1000 words, like that. So that's why when you are showing input images and output images for each image processing technique, you can remember easily lifelong, not only now, even after session also. So noise reduction is okay. This is the image having noise. After reduction, we are getting this type of image, like that. Suppose if I speak something about noise reduction, you won't remember after the session. So that's why for all the techniques, I will show input, output, and after that we will see how we are going to apply various image processing techniques to remove or maybe minimize the noise, and also hands-on by using Matlab. As you can see here, noise reduction. So this is a image with a lot of noise. This we can call it as a salt and pepper noise. That also I'll explain later. What is salt, what is pepper, what is, why we can call it as a salt and pepper noise or impulsive noise, how we are going to reduce that. All those things we'll discuss in detail when you are looking for image processing technique with hands-on Matlab. So just I'm showing here input output. So this is the input image. Here we have a lot of noise, and after applying image processing technique, so we can try to minimize or we can avoid the noise. So we can call it as a minimize the noise. So we can't avoid always 100% noise. We'll say minimize the noise. So output image, as you can see, so we reduce the noise when compared to the input image. So this is the input image. Let us assume A. This is the output image, and the transformation T we apply to the input image. That's why T of A equal to B. So that means Gxy equal to T into F of Xy, that we discussed just now mathematically how to represent. So this is called noise reduction. This is very, very important as a pre-processing techniques. So without pre-processing, if you go for further image analysis, sometimes you may get negative results. Instead of COVID positive, you may get COVID negative. Instead of COVID negative, you will get COVID positive. Or if you are looking for cancer detection, instead of cancer positive, you may get cancer negative, and vice versa possibility is there. Because of that reason, pre-processing is very, very important. So that's why noise reduction comes under one of the pre-processing techniques. There we can minimize the noise. Based on that, we can go for further processing, or we can call it as image analysis or post-processing of the images. So this we will see how to apply, what are the techniques we are going to apply to minimize this noise with mathematical intuition and hands-on. I'll explain later. And edge extraction. So this is the input image, and we are extracted the edges. When you go for some of the diagnosis of the diseases, we can go for edge detection, or maybe sometimes, just a second. Yes, sorry. Yeah. So when you come to the edge extraction, or we can call it as edge detection. So sometimes we have to detect the edges of the cells which are infected with cancer, or maybe sometimes we have to go for edge detection of the person, maybe for some applications. So such type of things we have to go for detecting edges. So how to detect edges and what type of applications we are going to do by using that, we'll discuss further. This is also one of the image processing techniques. And next one is very important, contrast enhancement as a pre-processing techniques. So as you can see here, this image having low contrast, so we have to go for further enhancement so that we can see better contrast, or maybe we can see objects clearly. So we have various contrast enhancement techniques are available. Based on that, we can improve the contrast. So input image, that is called F of XY. After applying contrast enhancement technique, we can go for output image, that is called G of XY. So we can see better contrast. Maybe we can look for same thing for color enhancement also. So whenever if you have a color image with low contrast, we can apply one of the image processing techniques. By using that, we can enhance the color contrast. So that I'll explain by using Matlab, as well as by using some of the image processing techniques. Only thing is, when you are looking for color contrast enhancement, we have to apply the image processing technique for each channel, because color image is a combination of 3 channels, that is called RGB. Just now we discussed, and we have to apply contrast enhancement technique for all the 3 channels. Red channel we have to apply, green channel we have to apply, blue channel we have to apply. After that, we have to combine all the 3 channels so that you will get output image as a color contrast enhancement of the input image. So that we'll discuss in detail, and how to decompose and how to later we have to combine all those things, we'll discuss later. And segmentation is, sorry, here also you can see this is the input image. After contrast enhancement, we are able to see, suppose if I want to count how many number of students in a classroom for attendance calculation, if the contrast is not up to the mark, then it is difficult to identify number of students. Let us assume 100. If the contrast having low, then instead of 100, maybe it may detect number of students 50, 70, 80 like that. Because by me, some of the students not able to see, then how the technique will detect number of students exactly 100. Because of that reason, when you are improve the contrast, when you are looking for contrast enhancement of the class, then obviously the system or maybe the camera will detect properly number of objects in the classroom. That means number of students attendance is 100. Like that, we can go for easily object detection also. Same thing, if we have heavy rainy season, suppose if someone is violating the traffic signal, then it is difficult to recognize the number plate. So for further processing, for sending the fine or maybe notice, so that's why we have to enhance. Even though camera captures the number plate, after that we have to go for pre-processing, that we can call it as a contrast enhancement. After that, we can identify the number plate easily. That means number plate means number easily, that whatever car number, then we can send notices to the person, you are violating the signal, you have to pay this much amount as a fine, like that. So such type of applications also, it will play a very, very vital role. Even segmentation, so this is the input image, let us assume this is called brain tumor. So after applying a segmentation, we can segment the brain tumor area. This is the brain tumor area in the output image. So based on the doctor will say you have a brain tumor, we have to go for further analysis or maybe further diagnosis. So this type of applications, we have to go for segmentation. Even if you take COVID-19 image, so a person having COVID-19, so after segmentation, the area infected with COVID-19, you can see in the output image. So then doctor will say you have COVID-19 and you have to go for further diagnosis. So for such type of applications, we can go for segmentation. So we have various types of segmentations that we'll discuss in detail. Even we'll go for execution of by using Matlab. And thresholding, of course, thresholding, one of the segmentation techniques. After applying thresholding, you are able to see segmentation of the given input image. So this is one of the main important segmentation technique. By using that, we can segment the given image into meaningful regions. So this is the segmented output image. So morphology, we have dilation. Dilation means we have to make small thing to bigger one. Erosion means bigger one to small one. When you go for object counting or object recognition, we have to go for morphology. So we will see what are the types of morphological techniques are available. By using that, what type of applications we are going to achieve, especially when you go for object count, etc. So we require this morphological operations, dilation, erosion. So by using that, how to go for finding the number of objects, or how to go for filling the holes, that is also one of the morphological operation that we will discuss in detail when you go for this concept. And image restoration, this is the original image, and after restoration we are able to see the number plate. In original image we are not able to see anything, so that means the number plate is not visible properly. So after image restoration, we are able to see number plate properly. So maybe this is a degraded image, old image, let us assume 10 years back image. After restoration, especially these are all very, very useful nowadays, because some old 100 years files if we found, or maybe 10 years back photos if we find, that obviously it is destroyed. Then what we have to do, we have to go for image restoration. Based on that, we can see better quality when compared to the original image. That's why image restoration also plays a vital role. Here also you can see before and after image restoration, we are able to see properly. That's why we require this image restoration. Here also before image restoration and after image, before restoration, after this is the input image. After image restoration, we are able to find better. And image compression, I already said, this is also one of the objective of image processing for better storage and transmission. So original image, this is the actual size, and after image compression, so the size reduced to 212. You can see, imagine, so 970 KB 212, how much we saved? Almost we saved 500 plus KB. So suppose if we want to store this span, we require, let us assume 1000 KB memory, but here we require around 220 KB memory is sufficient. We can minimize the memory also. Based on that, whatever memory minimize, that we can utilize to save other photos, maybe other images. So that's why image compression also very, very important, one of the image processing technique. So we have various techniques that we'll discuss. So here also, so we have 248 size. After image compression, we reduce it to 22K. So you can see, but even though we are not losing any information, we are reducing the size. That is called lossless image compression. So we are not going to lose any information, but we are reducing the size of the file. That's why we can call it as a lossless image compression. That we'll discuss later in detail. So these are the various techniques. So all those techniques we are going to discuss one by one with some of the image processing techniques in under contrast enhancement, segmentation, etc., and hands-on by using Matlab, so that we can understand how to implement also. And applications, whatever we covered there, only most of the applications are covered. What are the applications of digital image processing? Because nowadays image processing plays a vital role, and we required for computer vision, we required for deep learning, we required for machine learning, we required for other data science concepts, artificial intelligence concepts also, basics of image processing. So medical imaging. So this is one of the very, very important application. A lot of research is going on this medical imaging. So we can go for cancer detection, breast cancer detection. Whenever if I take image, this is the image, then wherever this is a part infected with cancer, skin cancer, we can go for segmentation. Based on that, we can go for diagnosis. Even breast cancer, even ultrasound imaging techniques also we have. So we can go for, this is the area infected with breast cancer. Based on that, we can go for further diagnosis. Even chest X-ray images. So these are the COVID-19 images by using imaging techniques. So with the help of deep learning or maybe direct image processing, we can go for detection of COVID-19. So whether the person having COVID-19 or not. So now we have a deep learning techniques. So by using some of the pre-processing, image pre-processing followed by deep learning, we can go for directly classification, whether the person having COVID-19 or not. Even one of the IIT professor proposed, developed a model, deep learning model. So within seconds, we can detect whether the person having COVID-19 or not, like that. So like that, we have huge applications for medical imaging also. Even malaria infected cells. So these are the original images, and after segmentation, that is called edge detection here, that is also one of the part of segmentation. Based on that, we can identify the cells are infected with malaria. So you can see this the segment edges are detected, the cells which are infected with malaria detected as edges. Based on that, we can go for further diagnosis. Suppose an image having no COVID infected cells, then you will get empty cell, there is no white color, you will get full black color. That understood that the person not having any COVID-19 malaria disease. Based on that, we can go for further step. Even biometric, because every day, so when you are entering the office, we can go for either face detection or a fingerprint. So most of the office people having a biometric means fingerprint recognition only. Just we have to put your finger whenever it will matches. Suppose let us assume this is the biometric, and here a person is standing here, and this is the data set or database. So whenever the person putting finger here, it will go to the data set database, and it will compare all the fingers. Whenever matching, again it will return, immediately will get. So you accessed it. So then it will calculate the time when you punched. Suppose if the fingerprint is not matching with any one of the databases fingerprints, then obviously you'll get error. Your access is declined. Please contact HR, like that. So this type of biometric applications, image processing plays a vital role. So there we have to apply image analysis. Based on that, we can go for segmentation, and by using that, we can go for recognition of the fingerprints. Even names also. Whenever if you go for bank applications, like when you put some signature in the checkbook, then obviously they have to go for cross verification of the original signature and this signature. So for such type of applications also, we can go for image processing techniques. Signature verification, just now I said. So when you are looking for signature verification also, so we have to go for image processing techniques. Even nowadays we have deep learning techniques also. By using that, we can go for signature. If of course there is no 100% verification, they will fix some threshold value, maybe if 90% verified. So because suppose if I sign something, again if I sign, there is little bit variation is there. We can't sign 100% same to same. 100% it is impossible. So because of that reason, they may fix some threshold value, 80% or 90%. If 80-90% matching with the database signature with the signature, the person who signed, then it will allow, okay, signature matching. Otherwise, you will get error, signature not matched. Then we have to go for further step. and here degraded images. So this is also one of the very important for document handling. Even there is a lot of research is going on degraded image analysis. So original image, as you can see, we can't read anything, the image is not proper. After improved image, we are able to see better. So this is called document handling. So degraded document analysis, you can check it in Google, just degraded document analysis using image processing. We can find lot of number of articles. So there the concept is this one. So this is the degraded image by using various it may be pre-processing or post-processing. Finally we can find the improved image. So this is the f of x by, that is called input image. And after that we have to apply some techniques, then we can go for improved image g of x by. Same thing at doc. So this is the latest old document, we are not able to read properly. Maybe after handling by using techniques, image processing techniques, we are able to read at least better, not 100%, better than the degraded image. Like fingerprint verification that we discussed already, and object recognition. Whenever we have objects, how to go for recognition, or maybe attendance calculation of object recognition we can do. And target recognition, because nowadays there is a war between Ukraine and Russia, so it's like a virtual war only. So they will recognize the target and directly they will hit, they will put bomb or maybe some kind of thing. So this is one of the very important application for this type of wars. So here you can see we are able to recognize the object. So these are the objects. Some tankers, bomb tankers are available. Immediately they will put some bomb on these tankers, so it will destroy. So this is called, almost it's like a virtual war. So this is called target recognition. Their image processing plays a vital role for recognition of the objects. Based on that, we'll go for further step, maybe destroying these objects, or maybe we can do some other action on this, like that. And aerial photography, this is also very important when you are looking for aerial survey or maybe Google Map applications, etc. And traffic monitoring, this is also one of the important application. So we can calculate how many vehicles today, Monday, these many vehicles are violating traffic signals, or maybe these many vehicles are going in this traffic. So obviously there is a huge traffic possibility even coming Monday also, we can go for further action. So like that we can go for traffic monitoring, or maybe it will show some other way. So maybe this road is very heavy traffic, just like a Google Map, so it will show other way. There may be less traffic we can find, and we can reach the destination within less time. Instead of 1 hour, you may reach 45 minutes, like that. So such type of traffic monitoring applications, so especially Google Map, etc., we can go for image processing, also one of the applications. And face detection, because when you go for biometric or maybe identifying the people, we can go for face detection by using image processing. This is also one of the important application. And face recognition, similarly what we discussed in the previous one. And autonomous vehicles, so for this also we can go for image processing. And image captures, so nowadays we have this image captures. Whenever if you open any bank account, or maybe you will get immediately security mechanism that is called captures. This is also one of the very important application of digital image processing. How to recognize the capture, whatever you have typed, so it should match with the original one. For that we have to go for a recognition of the letters or maybe characters. Based on that, it will, suppose if whatever type characters which is not matching with the capture, then again you'll get one more capture, like that. So otherwise you'll get message captures not matched, then again you have to enter. So for such type of applications, we can go for image processing with the help of neural networks or deep learning techniques. And video processing also, we require this images, noise reduction, all those things. And facial expression recognition also, we can use image processing techniques. And human activity, we have nowadays cameras, so everywhere, so there we can go for human activity recognition. So there also image processing plays a vital role. And morphing, so nowadays this is also one of the issue. So morphing, all those things happening in the online also. This is by using image processing techniques only we can do morphing. Maybe some good applications also there, some bad things also there because of this morphing. And image technography, so image technography means we have to hide information in the image. Based on that, no one can see the information, so that we can send image information secretly to the third person. So A is one person, B is one person, So A has to send some information to B. Of course, we can apply cryptography also. So, but when you apply image technography, we can hide the image, that we can call it as secret message in the normal image. After that, we can send to B. Then after that, you will go for decoding. Then you can see the message. Suppose if you send message hello, after decoding, B can see hello message. So there we have various image technography techniques. There we have to apply image processing. By using that, we can decode the message and we can see what type of message we have received from the sender. This is also one of the security mechanism for sending information from source to destination. We have one technique that is called least significant bit technique, LSB. So by using image processing techniques that is called LSB, we can go for image technography. So like that, we have huge number of applications. What we have discussed are a little bit applications. So still we can find so many applications of digital image processing. Now the question is, okay, we have various image processing techniques. So we discussed so many image processing techniques briefly, like input output image, and we know what are the applications of image processing. Now let us assume after let us assume after knowing all the information about techniques and now how to implement. For that we require some tool or maybe some software. So for that we can go for OpenCV or maybe Scilab or Image or Matlab. But in our FDP, our scope is Matlab. So we are going to discuss about Matlab, how we are going to implement image processing techniques by using Matlab. Even Scilab also we can apply. The difference is Matlab is a not open source. Scilab is open source. So but Matlab having huge applications and huge number of toolboxes when compared to Scilab. Suppose if you are not able to find the software, Matlab software, because it's not open source, maybe a student version or maybe 30 days trial version available in the mathworks.com, maybe that we can use for your practice. Otherwise we can go for Scilab, that we can download within 1 or 2 minutes only, and after that we can apply. Just a second. Okay, sorry for interruption. Yeah. So we have various image processing tools like Matlab, Image, etc. But our scope is Matlab. How we are going to implement various image processing techniques using Matlab programming. By using that, we will see what type of output we are going to generate for the processing of the given input images. Of course, Scilab also simple only, but only thing is it's open source and we can download without any further delay of this. But only thing is here we don't find much what we can call it as a toolboxes and advantages when compared to the Matlab. But for academic purpose, so we can go for Scilab, so that we can implement whatever commands we are going to discuss in Matlab, almost same for Scilab also. Maybe small minor changes except 1 or 2. But most of the commands what we are going to discuss by using Matlab, same thing we can apply for the Scilab also. So even recently I have delivered a talk, image processing by using Scilab. So same whatever concepts I'm going to explain for this FDP, same thing I explained there also. But only thing is I have implemented by using Scilab. So that's why almost 90 to 95% commands, everything is same. Suppose if you don't have MATLAB, so what you try to do, you try to download the Scilab. If you want, I'll provide instructions also. I have one PDF. So how to download and how to execute commands, Scilab commands or functions that I'll share. So based on that, suppose if you have MATLAB version, there is no issue. You can go ahead what we are going to discuss in the sessions. So now coming to the MATLAB, because our scope is MATLAB, how we are going to apply image processing techniques by using MATLAB. So MATLAB, actually MATLAB stands for MAT means matrix, LAB means laboratory. It stands for MATLAB matrix laboratory. It is developed by MathWorks. So even you can go through this MathWorks website and you can go for trial version also. I think 30 days trial version or maybe student version is available. So by using that, you can execute your all the commands or programs what we are going to discuss in this FDP. Suppose if you have in your college or maybe if you have MATLAB software, you can install and you can execute the command. So anyone, you have three options. One option is you can go through MathWorks and you can go for 30 days trial version, or if you have software already MATLAB, then no issue, you can execute with our all the commands or programs what we are going to execute, or in worst case you can take a Scilab and you can install and you can execute it. So easily you can go for same commands for Scilab also for image processing. So the main objective of Matlab is, so we can go for interaction, computation, better interactive computation, visualization, programming, GUI, like that. We have various type of objectives we have by using Matlab, and obviously it's a high level programming language, and we have various toolboxes are available. So what is the meaning of toolbox? Means set of functions or maybe set of libraries. Suppose if we take image processing toolbox, so no need to go write code for reading images, just we have one function, by using that we can read. So we have all the libraries available in the respective toolboxes: image processing toolbox, signal processing toolbox, data science or maybe machine learning toolbox, like that. We have latest versions, even machine learning, deep learning also available. So by using the toolboxes, if you download and if you install, then no need to write complete code, just you can use that commands, and based on that you can find directly output also. And of course, for image processing means Matlab is the most popular software used for digital image processing. Suppose in worst case, if you are not able to find the software, then we can go for Scilab, because in academics, even first year also now they introduced Scilab. Why? Means for small type of operations like addition, subtraction, maybe small digital image processing operations, such type of things we can go for Scilab also, because the syntax and the comments, everything almost same only. So I already said, so why we have to go, we have various toolboxes. Suppose if we take, let us assume Matlab. So we have various toolboxes. Let us assume image processing, signal processing, data science, or wavelets, or maybe fuzzy logic, neural networks, like that. So whichever required, for example, we required image processing toolbox, or maybe image processing computer vision toolbox, depends on our application we can download. Because of that reason, no need to write code for reading images, or maybe segmentation, or it may be conversion of the RGB to grayscale, etc. Because all the libraries are available, we can call it a set of MPIs. The extension of Matlab program is .m. So like C program is .c and Java program is .java. When you go for Scilab, I think SCI or SCL, like that, we have various extension for programming. But here Matlab programming means all the programs we have to say with .m, that is called Matlab programs. But we are looking for image processing toolbox only. So that I will show the installation process also. Based on that, you can install if you have software. So image processing toolbox, obviously we require, because all the functions are available for various applications of image processing, like pre-processing and segmentation, contrast enhancement or noise reduction, etc. And analysis also we require image processing like segmentation, etc. You can see some of the functions. So for example, if you take, let us assume hist eq. So this is the direct, just we can apply this function hist. This is called histogram equalization. Suppose if you want to write a Matlab program, it will take a lot of time to write. Instead of that, if you install image processing toolbox, directly you can use this function. By using this function, we can find, for example, hist eq. Let us assume the image is I. So when you apply this function directly, it will calculate the histogram equalization of the input image, and obviously it will go for further contrast enhancement of the input image, and we can show by using that we can display that, so that we can see better contrast enhancement of the input image. So like that, we have various im adjust and RGB to gray, like that, im read, like that. We have various functions are available in the image processing toolbox. So by using that, we can go for further processing of the images. Here just I have displayed the screenshot of that image processing toolbox. Like that, we have so many other libraries or maybe functions are available. You can see some of the image processing toolbox, image analysis. When you click here, we can find code for edge detection. Just you can apply input image, you'll get output. Image segmentation, image registration. Like that, we have various direct functions are available. By using that, we can go for edge detection, segmentation, contrast, enhancement, etc. Otherwise, we have to write a complete code. After that, we have to execute. It will take a lot of time. That's why we can go for image processing toolbox. Directive functions, ready-made functions are available. You can just give the input and you'll get output. It may be contrast enhancement, or it may be noise reduction, or it may be segmentation, or it may be edge detection, or it may be object recognition, or it may be object count, etc. Depends on the application. Yeah. So use Matlab for control systems, deep learning, because now we have deep learning, machine learning trend. Even you can apply for deep learning and robotics, but we are focusing on image processing. This is our main scope of our session. Just image processing, not even computer vision. Just we are focusing for Matlab for image processing, even robotics, wireless communication, even signal processing for EC students, EE students, machine learning, so interdisciplinary field. Like that, we can apply Matlab for these domains. Even you can see here various other domains also. Data science, here also you can see data science and measurement, wireless communication, etc. So the complete details are available in the mathworks.com. So this is a screenshot from mathworks.com. So they only developed this Matlab software. Even who uses this Matlab? So aerospace industries and biotech, pharmaceutical, healthcare industry, medical devices, I already said. So medical diagnosis, all those things we can go for Matlab. Semiconductors, they are using Matlab. Energy production, when compared to the Scilab, Matlab are using most of the industry because of so many libraries and so many GEO options we have in compared to Scilab. So Scilab maybe for simple academic purpose we can apply, but when you go for high-fi research or maybe industries, we can go for Matlab only. Of course, we have to pay money for the software also. So installation here, just let me check this one. I will show. Sorry, just a second. I will show. So installation instructions, I will show briefly. Maybe if possible, I'll share this if you have MATLAB software. So MATLAB installation instructions. So maybe here, so we have a MATLAB 2013 folder. There we have to click the setup button. Once if we click setup button, we have to, do you want to allow this app? Yes, we have to click yes. Just you can click yes. After that, then the installation process will start. And after that, we have to install without using internet. This option we have to click. So install. Anyhow, this document I will share to the organizers, then they may share to you. Install without internet. After it will take a lot of time for installation. It will take around 45 minutes to 1 hour. After that, next button, then it will start again installation. Do you accept terms? And yes, you can click yes and press next button, and we have to enter the installation key that is available in the folder. Just you can click this one and enter installation key. Here my installation key is 1245 something here. After pressing installation key, entering installation key, next button we have to click. Then after installation type as typical we have to type. Once then press next, and we have to specify the folder where we are going to save the MATLAB software. So maybe if you are not specified, by default somewhere it will save, and in search if you type MATLAB, automatically you will get, and you can open for executing the programs. And here is installation folder you can specify, and install. It will take time here around half an hour or 45 minutes. You can see here about 145 minutes, as you can see here. Once if you press installation, about 145 minutes it will take here. Depends on internet speed also. Obviously internet connection is required here. So while installation of the toolboxes, all those things we require even when you are trying to install toolboxes in Scilab also, internet connection is mandatory. Without internet connection we can't install. After installation, so installation is processing. Then finally, you can see the next button and active manual without internet and the next button. And license we have to update license.dat file. That file we have to update here. And after updating, we have to press next, and activation is completed. Matlab activation is completed. Press finish here. Then in such, you can type Matlab, you can find like this Matlab or 2013A. Just you can double click, then it will open. So it will here loading, or I have this or 2013A. Of course, latest version also we have in our lab book, but not in my laptop. So after once loading, then finally we'll get like this. So we have a window, Matlab window. Maybe we can say Matlab editor also later. So this is a simple way for installation process. Later I will share this document also if you want. Based on that, we can install Matlab in our system also. So just I have moved a little bit fast about the document because it will take time to install. That's why later I will share. You can go through that instructions because step by step I have given, and with screenshots also. Based on that, you can understand easily. So after installation of the Matlab, so suppose if you don't have Matlab, don't worry, you can go for Scilab. That also, if you want, I will provide instructions for installation. So whatever commands we are going to execute here, that we try for Scilab also. If not, you can go for Matlab only. So when you open Matlab, installation done. When you open this is called Matlab work environment. Here you can see this is called command window. Everything is clearly available. Command window. Here you can type the commands. Let us assume 2 + 3, then you will get 5 like that. And this is the, but it won't store permanently. For that, we will see what we are going to do. This is just we have to type. Suppose if you type 2 + 3, enter, you will get 5. Suppose a equal to 8/2, if you press enter, you will get 4 like that. So whatever, if you want to execute small commands or maybe imread, so some image, then it will read, and you display show you will get output of the image like that. So this is command window. Small commands we can execute, but these commands won't be stored permanently. For that, we have to go for Matlab editor. So there we can write a program, and that programs will be stored permanently like C program, C++. And this is a workspace, and here all the variables, whatever variable, suppose if I use a, this variable name, suppose a equal to 5 here, and the variable name a, value 5, minimum like that, maximum it will store. So all the in workspace, we can find all the variables, whatever we are using in the command window. And here command history, what is the meaning? Suppose if I type C equal to a plus b, that command history it will display here, C equal to a plus b like that. All the command, whatever commands we executed, complete history is displayed here. And here this is called current directory contents. So what is the current directory content means? So whichever directory we are going to, whichever folder you are going to use, that details it will display. Suppose I'm using this Matlab folder, whatever images, files, everything, it may be JPG images or any other format images, and Matlab files, .m extension, all the data, whatever data in this folder, it will display here. So, and file details. Suppose here, let us assume FDP 10 image is there, .jpg. If we click this one, you can find the details here. So what is the size of the image, all those things. So that is the meaning of file details. And if you press any other image, maybe other folder, maybe other document, that details will be displayed here. So this is a brief Matlab work environment. Here command window, here whatever commands we are going to type will get output, input output we can give here, and workspace, all the variables list will display here, and command history, whatever commands we executed, that command history is available here, and current directory, whatever current directory you have to choose. Because here very important thing is, whenever if you want to use some reading images, then the current directory should be that image folder. Suppose I have saved the images in Matlab folder, but the current directory is something else, then you won't get output. You will get image file not found like that. So always the current folder should be a folder where our images, whatever input images we are taking, that images should be stored in that folder. So that's why always the current directory should be the folder where we are using the images. Otherwise, you will get image not found, such type of errors will get. Anyhow, during hands-on, I will show all those things. And here you can see some small examples. So here C equal to 5 + 6, the output is C equal to 11. Immediately you'll get in the workspace, the variable information is displayed, C equal to 11. output minimum is 11, maximum also 11 you will get. And d value, d equal to 8 by 3, so 8 by 2 4, so that's why d value is 4. Like that, all the information variable information displayed here. And command history, whatever commands we executed, suppose here d equal to 8 by 2, the command history you can see here, last one, that is the last command history, 8 by 2, c equal to 5 by 6, all the command history is also available here. And here this is the current folder, whatever folder I'm using for images, this is the current folder. So here image 5, when I highlighted this, all the images are available in my current folder, that is called Matlab images. So FDP 5, when I click this one here, I can find the image details. That means the file details, width is 300, height is 168, like that. So number of rows, number of columns displayed here. So such type of information, but most probably we require this command window for executing. Even if we are going for Matlab editor, there if we execute any program, if we get any error, it will display here. Let us assume image is not found, or maybe variable is missing. Such type of errors also will display in the command window only. Anyhow, all those things I'll explain through hands-on. Based on that, you can understand. And this is called Matlab editor. So whatever commands we are executing here, it won't be stored permanently, but whatever program we are writing, it should be stored permanently. So for that, we have to go for Matlab editor. Here we have to write a program and we have to save it and execute, and this program will be saved permanently. And extension of that file is Matlab file is .m. Anyhow, these things I'll explain in detail by opening Matlab software. I already installed, just I will execute through hands on all those things, you can understand. Just I'm showing the screenshot, whatever I explained, all those things I'll explain through hands on. So like this. So when you come to the latest Matlab software, we can find command window and Matlab editor together. Like this, you can see here only command window. When you go for before 2000, I think Matlab or 2012, before that versions, we have separately command window. But Matlab 2013, I think 1.2 onwards, we have like this command window also incorporated with the Matlab editor. You can see Matlab editor here. I mean Matlab command window. So you can write the programs here. If you have any errors, we can find here only immediately. So anyhow, these things I'll explain clearly during hands-on session. So these things leave it. So all these hands-on I'll explain clearly. And all the Matlab, I thought to complete this image processing basic Matlab functions, but almost we have 4:30. So these Matlab functions, hands-on, all those things tomorrow I'll explain. So how to execute these Matlab functions in the command window, as well as Matlab editor, how to execute, how to read images, how to display, how to do Matlab operations, all those things I'll explain tomorrow. These things I'll explain tomorrow clearly with hands-on. Now onwards hands-on only, because theoretical aspects we completed. Now tomorrow we'll start hands-on, all the programs will execute, and we will see what type of output we will get and what type of image processing techniques we are going to apply. Everything I'll explain tomorrow onwards, hands-on also. This no need to worry, this I'll explain clearly later. Yeah. So now hands-on is left. Whatever we discussed, this hands-on I'll explain tomorrow session. And if you are looking for further enhancement of this Matlab image processing, so you can go for this textbook digital image processing by using, by Rafael Gonzalez. So this is one of the best textbook for digital image processing. Suppose if you are not able to understand, you can go through with any local textbook also fine. But I suppose if you are beginner for digital image processing, it is difficult to understand this textbook. In that case, you can go through with any local textbook. Based on that, you can understand. Then you can come back to this standard textbook. And digital image processing using Matlab, same author only. Here you can find Matlab functions, commands, all those things. And if you have any further questions, you can unmute and ask me, or you can type your query in the chat box. And tomorrow, whatever I have explained today, all those things will go for hands-on. So Matlab will go for hands-on, how to read images, how to do processing, how to go for contrast enhancement by using image processing techniques. So everything tomorrow you'll see hands-on. So when you are looking for hands-on, first I will show the comments in presentation with screenshots. Then same thing I'll execute through Matlab version, and you can see the hands-on also. So if you have any queries, you can type in the chat box, or you can unmute and ask me. I'm happy to answer. So that is the end of day one session. So today we have not done any hands-on, but these things, whatever we discuss tomorrow, we'll start with hands-on only. So there is no, because we completed all the theoretical aspects. What is digital image? What is digital image processing? What are the digital image processing techniques? What are the applications? What is Matlab? Why we require Matlab instead of Scilab? All those things we discussed, and what are the basic Matlab functions? All those things we'll go for hands-on tomorrow's session. Okay, thank you all. So we will meet tomorrow, and tomorrow we'll start with hands-on by using Matlab for digital image processing techniques. So that was my talk, end of the session. So thank you. We'll meet tomorrow. If you have any
Thank you, sir, for the wonderful session. And thank you so much for the presentation. We appreciate you taking time out for the due day to give an informative session. I believe that the first session of the FTP was informative for all. And the next section will start sharply at 3 p.m. tomorrow. On behalf of IFRP, I heartily thank all the professors, academicians, and delegates who have joined us today. I would like to extend my gratitude to our esteemed speaker, Dr. J. Somashekar, for delivering the keynote address. Thank you all.
Thank you.